continuous random variables. In the last two videos we discussed about discrete random variable, and there are two types of distribution under discrete, that is binomial and Poisson distribution. So far, if you have not watched those videos, in the description box I have given the links. Once you watched, then we will try to discuss the third video, that is today I am discussing about continuous random variable. First, let us try to understand the definition. If a random variable takes non-countable number of values, then it is called continuous random variable. So in general, continuous random variable always takes any value in the interval of real numbers. So that is the definition of continuous random variable. If you studied in the case of discrete, it takes only discrete values, but here it will take infinite number of values in any interval of real numbers. Say for example, observing the variation in the voltmeter, right? So if you put in a connectivity and check the variations, it may give any value, right? Say 5 volt, 5.5 volt, 5.45 volt. So all these things come under continuous. Even if you want to check an height or weight of the object, that is also come under continuous random variable, because it may also take any value. Say weight is 5.5 kg and height is 4.5 feet. So all those things come under continuous random variable. So thus we conclude that all measuring problems leads to continuous random variable, and all counting problems leads to discrete probability variable. Now let us try to understand the condition in the case of continuous random variable. Here, for every x belonging to the range of a continuous random variable capital X, we assign a real number f of x which has to satisfy these two conditions. Here what are the conditions? F of x must be greater than or equal to 0, and integration minus infinity to plus infinity f of x into dx must be equal to 1. Then f of x is called a continuous probability function or probability density function, in short PDF. You just recall once, in the case of discrete, what are the conditions we have taken as p of x? The first condition remains same, that is p of x is greater than or equal to 0, but the difference is, in the case of discrete, summation px is 1, but here it is interval from minus infinity to plus infinity. Suppose you take a particular interval, say a to b, then this becomes p of a less than or equal to x less than or equal to b. In place of minus infinity to plus infinity, we have to take a to b, f of x into dx. So this condition is important, because in most of the problems they mention the interval. Now, in the case of continuous, what are the values of mean and variance? So mean is integration minus infinity to plus infinity x into f of x dx. In the case of discrete, what is the formula? Yes, it is summation x into p of x. And variance, it is again minus infinity to plus infinity x minus mu whole square f of x into dx. So remember, here it is in terms of integration and limit is minus infinity to plus infinity. If they specify the interval, that interval and limit we have to take. Okay, now let us try to understand this definition with one simple example. Now, what is the question? Which says, find the constant k such that f of x equal to kx square, it is 0 to 3, in all other cases 0, is a probability density function. And also we have to compute p of 1 less than x less than 2, p of x less than or equal to 1, p of x greater than 1, as well as we have to compute its mean and variance. Okay, first we will try to understand the given function. What is our first job? We have to find the value of k. Observe the function carefully. This function defined only from 0 less than x less than 3. In all other cases it is 0, correct? Okay. Now, what is the first condition? In the case of continuous, it should be greater than or equal to 0. Okay, fine. As well as the second condition is integration minus infinity to plus infinity f of x into dx is 1. So we will substitute the value. Now interval is only 0 to 3, because in all other cases 0. F of x is kx square into dx equal to 1. K is constant, keep outside. Integration of x square is x cube by 3 equal to 1. So when you simplify, you get answer of for K as 1 by 9. So first part is done. Now what is the second question? Find the value of P of 1 less than x less than 2. I already explained, if they have given the interval, that limit we have to take. So here 1 and 2. So lower limit is 1, upper limit is 2. F of x into dx. Actually f of x is kx square, right? But k value is 1 by 9. So it is x square by 9 into dx. So very simple integration. You get the answer as 7 by 27. Now what is second one? P of x less than or equal to 1. That means what? Maximum value is 1. And lower limit, actually we have to take minus infinity, right? But minus infinity to 0, anyhow function is 0. So that's why I have taken 0 to 1. F of x into dx. F of x is x square by 9. When you integrate, you get answer as 1 by 27. Now, P of x greater than 1. Greater than 1 means starting point is 1 and upper limit actually infinity, right? By definition. But here function defined only up to 3. So, 1 to 3 f of x into dx. When you integrate, answer is 26 by 27. Next, mean. Write down the formula first. Minus infinity to plus infinity, x into f of x into dx. But here function exists only from 0 to 3. So integration becomes 0 to 3, x into f of x is kx square, but k is 1 by 9. So x square by 9 into dx. So you get x cube by 9. Integrate, simplify, you get answer as 9 by 4. Last, variance. Write down the formula first. It is minus infinity to plus infinity, x square f of x into dx minus mu square. But mu just now we found out 9 by 4 and limit is 0 to 3. Simplify and get the answer as 27 by 80. So this is the simple example for continuous probability distribution. Now, same thing in the case of discrete also, we studied two types of distribution, right? What are the two types? Just recall once. First one, binomial distribution, and second one, Poisson distribution. In the same thing, here also we have two types in the case of continuous probability distribution. One is exponential distribution, one is normal distribution. So in this video, I'll just explain exponential distribution with example. In the next video, I'll explain the introduction part of normal distribution as well as problems. Okay. Let us try to understand the definition of exponential distribution. What the definition says? The continuous probability distribution having the probability density function f of x equal to alpha into e power minus alpha x for x greater than 0. In all other cases it is 0, where alpha is constant. So this is called exponential distribution. You remember, only for x greater than 0, function is alpha into e power minus alpha x. In all other cases it is 0, where alpha represents constant. Now, again, in the case of exponential distribution also, you have to remember the formula for mean, variance and standard deviation. What is mean? 1 by alpha. Alpha is constant. Variance is 1 by alpha square and standard deviation is square root of variance. So again this becomes 1 by alpha. So what is the observation here? So in the case of exponential distribution, the value of mean and standard deviations are same. Okay. So this is the definition and formula for exponential. Now let us try to understand this with an example. I'll take two examples. First one. If x is an exponential variate with mean 5. So they have given x is exponential. They have given the value of mu, that is mean is 5. Then we have to evaluate p of 0 less than x less than 1. Second one, p of minus infinity less than x less than 10. And third one, p of x less than or equal to 0 or x greater than or equal to 1. Okay. First, since they have given this is exponential, write down the formula first. What is the formula for f of x? Just now we discussed, that is f of x equal to alpha into e power minus alpha x for greater than 0x, other cases it is 0. So same formula, can I write like this? That is f of x equal to alpha into e power minus alpha x for 0 to infinity. Correct, because here if x is greater than 0, then only function exists, right? In all other cases it is 0. So instead of writing second one, I have just written alpha into e power minus alpha x, but x value 0 to infinity. Okay. Now what is the given data? They have given mean is 5. But in the case of exponential distribution, mean means 1 by alpha. So 1 by alpha equal to 5. I want the value of alpha, so alpha equal to 1 by 5. Substitute in f of x. So what do you get? F of x equal to 1 by 5 into e power minus 1 by 5 into x. Done. We got the formula. Now what is the first question? We have to find p of 0 less than x less than 1. Again remember, this is integration. So 0 to 1 f of x into dx. So here it is 0 to 1, 1 by 5 into e power minus x by 5 into dx. 1 by 5 is constant. Integration of e power minus x by 5 is e power minus x by 5 divided by minus 1 by 5. Simplify, you get answer as 0.1813. Second one, p of minus infinity less than x less than 10. Again same, lower limit is minus infinity, upper limit is 10. But here by the definition, minus infinity to 0, function is 0, right? Only 0 to 10. F of x is 1 by 5 into e power minus x by 5 dx. Integrate, you get answer as 0.8647. Now last one, p of x less than or equal to 0 or x greater than or equal to 1. Just to recall the basics of probability, what is the formula says? P of A or B is always equal to P of A plus P of B. And if they ask P of A and B, that is P of A into P of B. So R means plus and means product. Okay. So here they are asking R, so plus. So P of x less than or equal to 0 plus P of x greater than or equal to 1. Anyway, if it is less than or equal to 0, by the definition of exponential, it is always 0, right? 0 plus. Greater than or equal to 1, so lower limit is 1, upper limit is infinity. F of x into dx. Now f of x is 1 by 5 e power minus x by 5. As usual, same integration. Substitute, simplify, and you get the answer as 0.8187. So that's all from the first problem. Let us take one more example for the clear understanding sake. Okay, what is the question says? The length of telephone conversation in a booth has been an exponential distribution. Remember, they have mentioned an exponential distribution and found on an average to be 5 minutes. So remember, on an average means mean, right? Find the probability that a random call made from this booth ends less than 5 minutes, and second one between 5 and 10 minutes. Okay. Again, is the exponential distribution. We know the formula, same method. Here they have given average is 5 minutes. Average means mean. So 1 by alpha equal to 5. Again alpha is 1 by 5. So what is the formula? F of x equal to alpha into e power minus alpha x. Here x lies between 0 to infinity. In place of alpha substitute 1 by 5. Now what is the first question? Ends less than 5 minutes. Less than 5 minutes means p of x less than 5. So actually we have to write minus infinity to 5, correct? But minus infinity to 0, it is anyhow 0. So we have to take only 0 to 5 f of x into dx. What is f of x? It is 1 by 5 e power minus x by 5 into dx. Integrate, you get the answer as 0.6321. What is the second question? Between 5 and 10, that means p of 5 less than x less than 10. So integration is 5 to 10, 1 by 5 e power minus x by 5 into dx. Integrate, you get the answer as 0.2325. I hope you understood this topic. In the next video, we will discuss about normal distribution. So that is very interesting. With this, we will wind up this video. Thank you so much. Have a nice day.